Hi guys, welcome back. Now I am going to tell you about the Rutherford model of an atom. Rutherford model of an atom. See, he considered the important three theories. One is the electrons are revolving around the nucleus with high speed. So that means he considered the nucleus is at the center and the electrons are revolving around the nucleus, and so both are held together by electrostatic force. Means it's also called as a Coulombic interaction. Second one, so he considered the nucleus, what he called, that is a hard mass or the dense mass present at the center of an atom. So that means it occupies the very small part of an atom. That means the atom size of an atom, that was the 10 to the power minus 10 meter. Then he considered this what the atom size. Okay, this is the atom size. Okay, so atomic size. Then nucleus size, he considered nucleus size, he considered 10 to the power minus 15 meter. That means the size of the nucleus is very small, much smaller than the atomic size. Next, the third is the most of the part of an atom, is empty, and the center part is occupied by hard dense mass called nucleus. So how he considered these points? That means he carried out an experiment. It was very simple. He considered it is a source of light. This is where it emits alpha particle rays. He made to pass it through slit. Okay, through the slit. When the radiation came here, he allowed to made it to fall where? On the gold foil. He kept the gold foil here, and the radiation is made to fall. Okay, the beam of radiation is made to fall on the gold foil. It is the photographic film. So when the radiation is made to fall on the gold foil, here what he observed, most of the rays were transmitted through the foil or the gold foil. Only few rays were deflected or some were bounced back. Then what he observed, the conclusion he made, that means For example, if it is an atom, if it is an atom, here there is a center, the nucleus, and around in a particular orbit electrons are here. Electrons are there. Okay, electrons. Now, when the radiation is made to fall here, what he observed? Here, what are all the rays fallen on the rays fallen on the nucleus? It is a nucleus. Okay, it is a structure of an atom. It is an atom. Okay, it is an atom structure. So, what are all the alpha particles fallen on the nucleus? It bounced back. And what are all fallen at the edge? Those deflect with a certain angle, and the most of the radiations are passed through the empty space. So because of that, we know that alpha particle is positively charged rays. Positively charged rays. How it is made? By from the helium. That means, for example, we know that the atomic number of helium is 2. If the 2 electrons are removed from the helium atom, then it will possess 2 plus charge. So the rays of this particle, when it is able to pass on the atom, it is sometimes it is what? Deflected, some are transmitted or passed through the atom, and some bounce back. Based on this, he concluded these 3 conclusions. So hope I have given you a clear picture. And one more important concept that you should know: the number of electrons that present in each shell. He proposed an important rule one should know, that is 2n square. It's very, very important. So according to that, in each shell electrons accommodate in a particular orbit. So where n is shell number. So because of that, for example, if you wanted to know the number of electrons that can accommodate maximum in n is equal to 1, that is, in n is equal to 1, you can see, if you put n is equal to 1, you will see 2. If you keep in n is equal to 2, if you put n is 2, means in shell 2, then you will get number of electrons 8 you can put. It will possess number of electron 8. n is equal to 3, if you put n is equal to 3, how much? It will become 18. n is equal to 4, if you put, you will get 32. Like that, in the first shell is a fixed, is a constant. So that means the number of electrons in the first shell, you will see only 2 electrons. In the second shell, you will see 8 electrons. Third, 18. Next, 32, like that, according to the 2n square. So according to that only, you have to accommodate the electrons. So those are very helpful while writing the electron configuration of any atom. Hope you have understood. Thanks for watching.